My name is Olivia Zoe. I'm in 7th grade and I go to Minnetonka Middle School East. My project is on how magnets affect seed germination. I chose this project because many people have vegetable gardens, but sometimes germinating seeds can be challenging. So I saw scientists using magnets around plants online, so I wanted to test what the impact was, and also to help people germinate seeds at home and at low costs. So before I started, I did some research. I found out that the salt molecules are modified so that the water is pure and it helps the plant take in more nutrients so it grows faster, and that different settings affect the plant differently. So some might grow taller and some might not show much of a difference. So my project is on testing to see if those home settings actually play an impact and what the seeds do. So my big research question was, how does magnetic field strengths, exposure times, magnet directions, and seed types affect their germination in a week's time? And I hypothesized that 1, different plant seeds had different growth. 2, longer exposure times would lead to more growth. 3, different magnetic directions would also have different growth. And 4, more magnetic strength would be a taller plant. So here's how I designed my experiment. I use the design of experiment method to conduct my project. So I had 4 levels of independent variables, 3 seed types, 2 magnetic strengths, 2 exposure times to the magnet, and 2 directions. So if I were to use all the combination, that would be those 4 numbers multiplied together and then multiplied by 5 trials for each container, so that would get me 120 runs, which is a lot. So I decided to use the fractional factorial, which is 12 runs, so half of the 24, and 5 trials, so 60 seeds. So the way design of experiment works is that if I were to test one factor, so let's just say peas, then all the rest of the variables would be balanced out. So there's 2 magnets on the bottom and then 2 on the sides, 2 that have 4 days of exposure time and 2 that have 7, and so on. When I average experiments 1 through 4, all the other variables are balanced out, so I can only test the peas compared to the others. So here's how I set up my experiment. I had 12 runs and 3 control groups under the growth lights, and some had 2 magnets and some had 1 magnet. So the magnets were either taped to the sides like this one, so that the magnetic field went through the container, or there was 1 magnet that was taped to the side or bottom, so the magnetic field goes either around or through, like vertical or horizontal. And here's the last type. There was 1 on the top and 1 on the bottom. So if I turn the magnet around like this, they would repel each other because it's north to north and then south to south. But if I flipped it over again, they stick to each other because it's south to north and north to south. So the magnetic field goes through the seeds in the container. Also, each number on the container corresponds to which experiment run it is on the table. And the 5 trials represents 5 seeds in each container. And I used a caliper to measure how long each seed was, so you can slide this back and forth. So I used a caliper to measure the peas and all the other seeds too. So there were 2 types of seeds. The top one, this one, it was easy to measure because I could just place it on either side. But like this one down here, it was it isn't just a straight line, so I have to add like the green section up, like with the other sections, like so this one from the P to the top, and then from the top to the bottom of the red. So I tried to get it as accurate as possible, but I would have to find a different way to measure it more accurately. And here's the data I collected. So the top graph shows the averages of each day, and the bottom graph shows the growth rates, which is measured by taking the average of that certain day and then dividing it by the average of day 0. And again, in the future, I would change how I measured my seeds, which was very challenging. So on the right side here are my observations. I took a picture of each plant every day, and I plotted them into a graph. So for the peas, the 4th experiment, I grew all the rest, and that was the one where it had one magnet on the top and one magnet on the bottom. And I think it's because the magnetic field goes through the container, so it's closest to the plants. And for the Brussels sprouts, I couldn't really make much of a conclusion because only 2 of them sprouted, and they were both in number 8, which had one magnet on each side. So the Brussels sprouts just didn't germanize. And lastly, I have the cucumbers. In this one, number 9 and 12 grew the highest. So in all 3 of these graphs, the blue line, the dotted one, is the control group, and something in all of the graphs was that the ones that received a magnetic treatment grew taller than the ones that didn't, which indicates that the magnets were helpful. So I plotted all the data into some graphs here. In the top left is the comparison of the plants that use magnets versus the control. And in all of them, the ones with magnets outgrew the control group. In the top right is the graph of how magnetic strength impacted it. So is it stronger to have 2 magnets or 1 magnet? And it shows that 2 magnets have a stronger reaction. In the bottom left is the effect of magnet direction, and if the magnets are placed on the bottom and the top, they are higher than if they're on the sides. And the last one is bottom right, effect of exposure time. So up until day 4, they were about equal, and then as I took off the magnets on the ones that had a less exposure time, the ones with magnets eventually outgrew the other ones. So then I came to these conclusions that 1, different seeds would have different growth, 2, different exposure times or a longer exposure time would lead to faster growth, 3, more magnetic strength would lead to faster seed growth, and 4 different magnetic directions would have different growth. These were correct, but some of them had the exception of Brussels sprouts, which again didn't sprout, except for 2 of them. So if I were to do this experiment in the future, I'd have a better seed type for instead of the Brussels sprouts, so that I could get more accurate data. So then I did a reflection. There's 2 main points I want to point out. So 1, the improvements. In the future, I'd spend more time researching what seeds work better with what magnetic fields, so I can have better data instead of just a plant that has 2 seeds that sprout. So in my case, that was the Brussels sprouts. And I'd redesign the design of experiment regarding magnet strength, because I could make that have a wider variety. So instead of just having 1 or 2 magnets, I could have it go up to like 3 or 4. And I'd also extend this experiment so it was more than a week. My second point is how this experiment applies to the real world. So my experiment shows that if you use the right magnetic treatment on plants, it can really benefit them. And farmers can use this as guidance to improve seed germination and boost crop yields, which can lead to more efficient and sustainable farming practices. Thank you.